Today, Llyn Igiau lies within the mountains of northern Wales, above the Conwy Valley and the village of Dolgarrog. Water gathers here among steep slopes, exposed rock and upland streams. From the valley below, much of this catchment is hidden from view, yet its elevation gives the water stored here considerable potential energy. That energy attracted industrial development during the early 20th century. Dolgarrog grew around an aluminum works whose machinery required a large and dependable electricity supply. Hydroelectric power offered a way to meet that demand by collecting mountain water and directing it downhill through turbines. The system was larger than a single dam. Reservoirs, channels, pipelines, and power station equipment linked the uplands with the industrial site below. Each component controlled part of the journey. Water captured at height could be stored, transferred, and then released through generating machinery before entering the river system in the valley. This arrangement brought two contrasting landscapes into direct dependence. Above were sparsely populated mountains holding large volumes of water. Below were homes, roads, a railway, industrial buildings, and the people whose work supported the growing settlement. Llyn Igiau became one of the principal reservoirs within this network. Its dams stretched across the natural outlet of the lake, increasing the quantity of water that could be retained. The barrier was built largely as an earth embankment, with a concrete core intended to prevent water passing through it. An embankment dam does not resist water by behaving like one solid wall. Its stability depends on the condition and shape of the earth around its watertight core, the strength of the foundation beneath it, and the safe management of water entering the reservoir. Drainage structures and spillways must control flows without allowing erosion to undermine the barrier. The surviving landscape reveals the scale of the engineering ambition. The dam occupied a broad section of the valley, while the mountain slopes formed the reservoir's natural sides. From here, water could be transferred towards the neighboring Coety Reservoir and then used by the hydroelectric works at Dolgarrog. The system was built in stages. Different structures had distinct functions, but they were hydraulically connected. A failure at one point could therefore affect water levels and flows somewhere else. Understanding the disaster requires following that connection from Llyn Igiau through the upland water system and down towards the village. Contemporary accounts and later investigations raised concerns about the construction of the Igiau Dam. The embankment crossed ground whose underlying conditions were not uniform. Sections of the concrete core were supported differently, creating places where movement or settlement could concentrate stress. The dam had shown signs of leakage before 1925. Leakage does not automatically mean that an embankment is about to collapse, but it can indicate that water has found a route through or beneath a structure. If flowing water begins carrying fine material away, a small internal path can gradually enlarge. Safe operation also depended upon the reservoir having enough capacity to accept incoming water, and upon excess flow being discharged without damaging the dam. In a mountain catchment, prolonged heavy rain could change those conditions rapidly. Streams that were normally modest could deliver large quantities of water into the system. By late October 1925, the region had experienced sustained rainfall. The ground was saturated, streams were running high, and water continued entering the upland reservoirs. At Llyn Igiau, the dam stood between the rising catchment and the connected waterworks leading towards Dolgarrog. The people below could not see the developing conditions from the village. Their homes and workplaces occupied the narrow valley floor, more than 1,000 feet beneath the reservoir. The hydroelectric system that powered local industry had become part of everyday life, its dams distant and largely out of sight. On Monday, the the 2nd of November, the rain continued. Water pressed against a barrier whose safety depended upon its core, its embankment and the ground supporting them remaining intact. Before the day ended, part of that barrier would give way, releasing water into a system that led directly towards Dolgarrog. On the 2nd of November, 1925, the Hydroelectric Dam failed. A section of the embankment was breached, and water escaped from the reservoir into the steep valley below. The surviving photograph records the breach after the release. It shows the dam divided by a wide opening, with the reservoir drained back from the broken embankment. The water itself had already moved on, leaving exposed ground, scattered debris, and the remains of a structure that had been expected to contain it. The failure began at the western side of the dam, where the concrete core crossed the course of an old stream. At this point, part of the core had been built over a buried culvert. The foundation conditions beneath the barrier were weaker than the solid ground available elsewhere along its length. As the reservoir rose during the prolonged rain, water found a route through or beneath this vulnerable section. Material was washed from the embankment. Once that internal erosion began to enlarge the passage, the remaining earth could no longer contain the pressure of the reservoir. A small leak became a developing breach. As the opening widened, the discharge increased. Faster water removed still more material, accelerating the destruction of the embankment. The process fed itself until a substantial section of the dam had been swept away. The released water entered the Hydroelectric Valley and moved downhill through the mountain drainage system. But Dolgarrog was not situated immediately beneath the breached dam. Between Lyn Hydroelectric and the village lay another part of the hydroelectric network, the smaller Coety Reservoir. Water from the Hydroelectric breach flowed towards Lyn Coety. The incoming surge raised its level beyond the conditions it had been intended to manage. Water overtopped the Coety Dam and escaped into the channel leading down the mountainside. This distinction is important. The initial structural breach occurred at Lyn Hydroelectric. The destruction at Dolgarrog followed after the released water overwhelmed the connected system farther downstream. Contemporary descriptions sometimes referred broadly to the failure of both reservoirs, but the two structures did not fail in precisely the same way. At Coety, the flood entered the steep route followed by the waterworks towards the power station. Gravity now converted the stored water's elevation into speed. As the flow descended, it gathered loose earth, broken masonry, and rock. The mountainside did not provide a broad floodplain in which the water could spread and lose energy. It channeled the surge towards the narrow valley occupied by Dolgarrog. The same topography that made hydroelectric generation possible also concentrated the flood's descent. Large boulders were torn from the slopes and carried or rolled downhill. These became part of the moving debris, increasing the destructive force of the water as it approached buildings, roads, and the railway below. There was little time between the breach in the uplands and the arrival of the flood at the village. Communication systems in 1925 could not provide the rapid automatic warnings expected around modern reservoirs. Those in Dolgarrog had no direct view of Lyn Hydroelectric and no immediate way to judge what had happened above them. The disaster was also unfolding during the evening, when residents had returned to their homes. The flood did not strike every part of the village equally. Its route followed the terrain, concentrating destruction through the northern section of the settlement. One circumstance prevented an even greater loss of life. Many villagers were attending a cinema performance away from the principal path of the flood. Their absence from the affected streets reduced the number exposed when the water arrived. That fact would later become part of the story of Dolgarrog, but it could not protect the homes that stood directly below the descending torrent. The breach had released far more than water. It had transformed the reservoir, channels, and mountainside into one continuous path of failure. At Igiao, the critical weakness had existed where the dam crossed unsuitable ground and an earlier watercourse. At Koeti, the incoming surge exceeded the downstream system's capacity. Between them, structures designed to control mountain water instead directed it towards an inhabited valley. The flood now left the reservoir system behind. Ahead lay Dolgarrog's houses, the industrial works, and the people who had received no meaningful warning that the water above them was already on its way. The flood reached Dolgarrog as a mass of water, earth, and stone. Its path could be traced afterwards through the stripped ground and debris extending down from the mountains towards the valley floor. As the water descended, it broke through walls, entered houses, and swept structures from their foundations. Roads and railway infrastructure were damaged. Mud and wreckage spread across the lower ground, while large boulders came to rest among the remains of the village. The northern part of Dolgarrog lay directly in the flood's path. Homes occupied by workers and their families were struck with little warning. Some buildings were destroyed completely. Others were left standing beside areas where neighboring houses had disappeared. 16 people were killed, 10 adults and 6 children. The number was small compared with the population at risk, but only because many residents happened to be elsewhere when the flood arrived. A film was being shown that evening in the village cinema. The performance drew many people away from their homes and out of the area most severely affected. What had begun as ordinary entertainment became the accidental reason that a much larger part of the community escaped the flood. Those who remained in the affected streets faced a disaster that developed too quickly for an organized evacuation. The reservoir was high in the mountains, hidden from the village. By the time the sound and movement of the approaching water provided a warning, the surge was already descending through the settlement. The flood's route did not spread evenly across Dolgarrog. The terrain channeled it through a concentrated corridor. This produced a stark boundary between destruction and survival. Buildings within the path were overwhelmed, while places outside it remained capable of sheltering survivors and supporting rescue work. The aluminum works and hydroelectric infrastructure gave the village equipment, transport connections, and an organized workforce. Those resources became important after the flood. Employees, residents, and emergency responders began searching the damaged area, helping injured people and accounting for those who were missing. Darkness complicated the response. The flood had disrupted power and communications, while mud, unstable debris, and continuing water made movement dangerous. Rescuers had to work through a landscape altered in minutes, where familiar streets and property boundaries were obscured. The force of the water was visible in what it had moved. Boulders weighing many tons had been displaced from the mountainside. Their presence among the wreckage demonstrated that the flood had not behaved like a gradual rise in a river. It had descended as a fast-moving debris flow, capable of crushing buildings as well as inundating them. The destruction also exposed the physical connection between the village and the reservoir system above. Dolgarrog's industry depended upon water descending from the mountains under controlled conditions. On the 2nd of November, that control was lost, and the infrastructure intended to serve the community helped determine the flood's route towards it. Photographs taken in the disaster area show people standing among enormous rocks and torn ground. The human figure gives scale to a landscape that had been reshaped by the flood. What appears at first to be a natural field of boulders was associated with a sudden event that had passed through an inhabited settlement. In the days that followed, the search moved from rescue to recovery. Bodies were found among damaged houses and debris. Families learned who had survived, who was injured, and who would not return. The dead included members of the same households, giving the disaster an impact that could not be measured only by the total number of casualties. Survivors needed accommodation, clothing, and financial assistance. Community organizations, neighboring towns, and the aluminum company contributed to relief. Damaged services had to be restored, debris removed, and decisions made about whether homes could be repaired or should be rebuilt elsewhere. The disaster attracted attention far beyond the Conwy Valley. Newspapers published photographs of the breach, the ruined streets, and the boulders carried down the mountain. The images made the physical force of the flood comprehensible to readers who had never seen Dolgarrog or Llyn Igiau. They also encouraged a simplified description. A dam had burst and destroyed a village. The actual sequence was more complex. A breach in the Igiau embankment released water into an interconnected hydroelectric system. The surge overwhelmed the Coedti reservoir and then descended through channels and steep terrain towards Dolgarrog. That sequence mattered because responsibility depended upon more than identifying the first visible break. Investigators needed to examine how the Igiau Dam had been designed and built, what was known about its foundation, how water was transferred between reservoirs, and whether the system could safely manage extreme inflow. The condition of the failed dam provided important evidence. The breach had occurred where the concrete core crossed an old stream channel and a buried culvert. This was a location where the barrier did not rest upon the same firm foundation available elsewhere. Water passing through vulnerable ground can remove fine particles from an embankment. The process may begin internally, without an immediately dramatic change on the surface. As material is carried away, the root enlarges and admits more water. Eventually, the remaining structure can collapse into the growing opening. Prolonged rainfall supplied the conditions under which that weakness became critical. But rain alone did not explain why the barrier failed at a particular point. A reservoir dam was expected to retain water during wet weather. The investigation, therefore, had to distinguish between the natural event that increased the load and the structural conditions that allowed that load to produce a breach. Questions extended to construction practice and oversight. The dam had been built for an industrial water system rather than as a public water supply reservoir. At the time, Britain did not have a comprehensive national system requiring every large reservoir to undergo continuing inspection by independent specialist engineers. The people of Dolgarrog had lived below a large body of stored water without the protection of the inspection, monitoring, and emergency planning arrangements that would later become standard. Their disaster exposed a gap between the rapid expansion of reservoir engineering and the law intended to regulate it. As the village began rebuilding, the technical inquiry was moving towards a wider question. If a privately developed reservoir could place a community at risk beyond the boundaries of its owner's land, who should be responsible for proving that it remained safe? The answer would shape legislation, engineering practice, and the future management of large reservoirs throughout Britain. After the flood, residents gathered in streets that had become places of relief, mourning, and public attention. Adults and children stood among neighbors, officials, journalists, and visitors while the scale of the loss was assessed. The disaster had destroyed part of Dolgarrog, but not the community as a whole. Much of the village had escaped the direct path of the water. Survivors were housed, damaged services were restored, and work began on clearing debris from the affected ground. The aluminum works remained central to the settlement's recovery. Dolgarrog had developed around the industry, and employment at the works gave the village an economic reason to rebuild. Replacement housing was constructed, while the streets and infrastructure damaged by the flood were repaired or altered. For bereaved families, reconstruction could not restore what had been lost. 16 people had died within a small community. The casualty list included 6 children, and some families lost more than one member. Funerals and memorial services gave the disaster a permanent place in local history. The engineering investigation concentrated on the Hydroelectric Dam's foundations and construction. The breach had occurred where the barrier crossed an old watercourse. At that location, the concrete core was associated with a buried culvert and ground conditions that did not provide uniform support. The inquiry concluded that water had found a path through the vulnerable section, washing material from the embankment until it could no longer resist the reservoir. Heavy rainfall had raised the water level and contributed to the conditions of failure, but the investigation identified structural and foundation deficiencies as essential parts of the explanation. This distinction had legal significance. Describing the flood simply as an overwhelming natural event would separate it from decisions made during design and construction. Recognizing that the dam contained a critical weakness raised questions about whether that weakness should have been discovered before the reservoir was placed and kept in service. Civil proceedings sought compensation from the companies connected with the reservoir system. The legal arguments examined ownership, construction responsibility, and whether the exceptional rainfall could be treated as an event beyond reasonable anticipation. The outcome did not create a simple, comprehensive system of accountability for everyone affected. The deeper problem lay in the law itself. Britain possessed many reservoirs built during industrial expansion, but their safety was governed by an incomplete mixture of private legislation, local arrangements, and the responsibilities accepted by individual owners. There was no universal requirement for every large reservoir to receive regular examination by an independent, suitably qualified engineer. Dolgarrog provided a clear demonstration that the consequences of a reservoir failure did not remain on the owner's property. Water stored for private industry could threaten an entire downstream community. The public therefore depended upon the condition of structures it did not own, could not inspect, and might not even be able to see. The disaster strengthened the case for national reservoir safety legislation. In 1930, Parliament passed the Reservoirs Safety Provisions Act. It applied to large reservoirs capable of holding more than 5 million gallons of water. The act required qualified engineers to supervise the design and construction of covered reservoirs. It also established requirements for inspection and reporting, creating a formal professional role in confirming whether a reservoir could continue to operate safely. The legislation did not claim that an engineer could eliminate every natural hazard. Its purpose was to ensure that large reservoirs were examined systematically, that defects were identified by people with appropriate expertise, and that owners could be required to act when public safety was threatened. This transformed the lesson of Dolgarrog into a continuing duty. Reservoir safety could no longer depend solely upon the assumptions made when a dam was first built. Earthworks settle, water finds weaknesses, drainage routes change, and extreme weather tests structures in ways that ordinary operation may not reveal. Inspection had to continue throughout a reservoir's life. Later legislation developed these principles further, changing capacity thresholds, enforcement arrangements, and the duties placed upon reservoir undertakers and specialist engineers. Modern practice also gives greater attention to surveillance, maintenance, flood planning, and the consequences for communities downstream. The reforms cannot be attributed to one event alone. Dam safety had already attracted concern, and other failures had demonstrated the need for regulation. But Dolgarrog gave Parliament a recent and unmistakable example of what could happen when a large reservoir above an inhabited valley failed without an effective national inspection system. The disaster also left an engineering lesson about interconnected infrastructure. Igiao and Coedti were separate reservoirs, but their behavior during the flood could not be considered in isolation. Water escaping from one entered the other, and then followed the hydroelectric works towards the village. Safety analysis had to account for the system as a whole, including what might happen when one component overwhelmed the next. That principle reaches beyond dams. Infrastructure is often designed and managed as individual structures, while failure travels through the connections between them. A safe component can still be exposed to conditions created elsewhere. Responsibility, therefore, includes understanding not only how a structure operates normally, but how the wider system behaves when control is lost. On the mountainside above Dolgarrog, boulders carried down during the disaster remain among the trees and undergrowth. One bears a memorial plaque. The rock is both evidence and monument, a surviving measure of the flood's power and a marker for the people killed below. The landscape has changed since 1925. Vegetation has returned, water is again managed through the upland system, and Dolgarrog has continued through generations that know the disaster through family history, photographs, and the physical traces left on the hillside. The damaged Igiao Dam was not rebuilt as it had stood before the breach. Remains of the barrier can still be found in the remote valley, where the opening records the point at which containment was lost. The surviving works are no longer simply industrial structures. They form part of the historical evidence used to understand the catastrophe. In the village, remembrance has preserved the names and experiences behind the casualty total. The disaster is recalled not only as an engineering case, but as a night when families lost relatives, homes disappeared, and an industrial community had to rebuild around a path of destruction. The number of deaths does not describe the full scale of what occurred. 16 lives were lost, yet many more were endangered. The cinema performance that drew residents away from the affected streets prevented the casualty count from becoming far higher. Survival depended partly upon a coincidence that no safety system had planned. The flood began with prolonged rain, but rain was not its complete cause. Water exploited a vulnerable section of the Igiao Dam. The breach released a reservoir into a connected system. Coedti was overwhelmed, and the steep waterworks carried the resulting surge towards Dolgarrog. Each stage converted an existing weakness into a larger consequence. Unsuitable foundation conditions became internal erosion. Internal erosion became a breach. The breach became an uncontrolled inflow to another reservoir. That inflow became a descending flood of water, earth, and boulders. The chain could be reconstructed after the event because the landscape retained its evidence. The broken dam showed where failure began. The debris path showed where the water traveled. The ruined village showed what happened when an industrial reservoir system failed above a community. The regulatory response recognized that such evidence should not have to be gathered only after people had died. Large reservoirs required independent technical oversight before construction, during operation, and whenever their condition raised concern. That remains the central legacy of Dolgarrog. A dam is not made safe merely because it has stood through previous winters, nor does its remoteness remove its consequences. Stored water connects the structure to every home, road, and workplace lying below it. The memorial boulder makes that relationship visible. It began high on the mountainside and ended near the village because water had escaped from human control. A century later, it stands as a warning that the quiet surface of a reservoir can conceal an obligation extending far beyond its shore. On the 2nd of November, 1925, that obligation failed. The legislation, inspections, and engineering disciplines that followed were built upon the cost paid in Dolgarrog.